Good morning, good afternoon. Today I'll walk you through an important topic in computer architecture, memory cache mapping techniques. This presentation will explain how cache memory stores data and the methods used to map data efficiently. So cache memory is a small high-speed memory located between the CPU and the main memory. It temporarily stores frequently accessed data and instructions, which reduces the time it takes the CPU to fetch data from RAM. The faster the cache works, the quicker the computer responds. And cache memory has key characteristics depending on the size, the access time, and of course, it's expensive compared to RAM. So you might be wondering why cache mapping matters. You see, cache has limited space, so we needed rules for deciding where to place incoming data from main memory. These rules are called mapping techniques. They help optimize speed, avoid conflicts, and make the most of the cache's limited space. Now we are moving on to the types of um, cake cache mapping. In direct mapping, each block of the main memory can only be stored in one specific cache line. It's simple and fast because it uses a fixed formula to find the location. But the downside is collisions. If two frequently used blocks share the same cache line, one keeps replacing the other. The advantage is its simplicity and speed. However, it's not very flexible. If multiple memory blocks compete for the same line, it leads to frequent replacements and even other parts of the cache are free. Now we are moving on to the associative mapping. So this method is more flexible. Any block of main memory can go into any cache line. It uses a tag to keep track of what data is stored where. While this improves performance, the searching process can slow things down due to the extra hardware needed to compare tasks. The biggest pro is that it reduces cache misses caused by conflicts, but it requires more complex hardware, which increases cost and power consumptions. It's better for high performance systems where flexibility matters more. Now, moving on to the last type of cache mapping technique, as set associative mapping. This is a this is a hybrid of the first two. The cache is divided into sets, and each set contains multiple lines. A block maps to a specific set, but within that set, it can go into any line. This balances flexibility and speed. So, for example, in a two-way set associative cache, each set has two lines, you see, and in a four-way, each set has four lines. So this reduces the chance of collision compared to direct mapping, while still being faster and simpler than full associative mapping. So this table summarizes everything. As direct mapping is fast but rigid. See, associative mapping is flexible but slow, and set associative mapping balances the two. So designers choose based on what matters most: speed, cost, performance, access time, um, complexity, and the hit rates. So we're moving on to some real world applications of these techniques. So in real life, direct mapping is used in simple cost sensitive systems like embedded devices like our mobile phones. Um, Associative mapping is found in a high-end computing system where hit rate is critical, and most modern general-purpose CPUs uses set associative mapping for a balance in their operations. So some challenges and future trends. Um, Cache coherence in multi-core CPUs and grows, The growing demand, like memory demands on the caches with larger datasets, and the power consumption in large caches consumes power. So the future trends, I think they're going to have an advanced replacement policies and 3D stacks caches for higher density and AI-driven cache management for dynamic optimization. To to wrap up, cache mapping techniques help determine where and how data is stored in each cache. Each method has trade-offs. Understanding them is essential for designing efficient memory systems and um, improving computer performance. Right. So this comes to the end of the whole presentation. If you have any questions, you can drop them in the comment section. And thank you again for listening.